Hello! In this video, we are going to prove the following theorem. Let F and G be families of sets. If the union of F is not a subset of the union of G, then there is some set A in F, such that for all sets B and G, A is not a subset of B. Now, if you recall, given a family of sets F, to say that X is an element of the union of F means that X is an element of some set in F. Okay, now, in proving this theorem, we're trying to prove if this is true, then this is true. So let's suppose that the union of F is not a subset of the union of G. And from here, we want to show that there exists a set A in F, such that for all sets B and G, A is not a subset of B. Okay, now to start, what does it mean for the union of F to not be a subset of the union of G? It means that there is an element in the union of F that does not belong to the union of G. And I'll call that element X. And since X is an element of the union of F, what does that mean? It means that X is an element of some set in F. And I'll call that set A. And our claim is that A is the set that'll satisfy this statement. So if we take A to be the A we have in our proof, we're going to show for all sets B and G, A is not a subset of B. So since we're trying to prove a statement about every set in G, give me an arbitrary set in G. I'll call it B. And now we want to show that A is not a subset of B, which means we want to find some element in A that does not belong to B. Well, maybe X satisfies that condition. We know that X is an element of A, so all that would be left to show is that X is not an element of B. Can we show that? Turns out, yes, because we know that X is not an element of the union of G. What does it mean for X to not be an element of the union of G? Well, we know what it means for X to be an element of the union of G. It means that X is an element of some set in G. So to say that X is not an element of the union of G means that X is not an element of any set in G. And since X is not an element of any set in G, well then in particular, since B is an element of G, we must have that X is not an element of B. So we see that X is an element of A, but not an element of B, which tells us that there is some element of A that does not belong to B. And that's precisely what it means for A to not be a subset of B. Now, putting this together, we see that under the assumption B is an element of G, it follows that A is not a subset of B. Since B was arbitrary, this means that for all sets B and G, A is not a subset of B. And that's exactly what we wanted to show. So we've shown that this is true, because if we take the A here to be the A we have in our proof, well, yeah, A is an element of F. That's what we have here. And we have shown that this is true. That is what we have right here, which is exactly what we wanted to prove. So this completes the proof. And so, yeah, that's pretty much it for this video.